Hey everybody, welcome back to another fun and exciting geometry class. Today we'll be talking about lesson 4.11, and that's the Pythagorean Theorem. That's on page 211 in your book, page 211. Pythagorean Theorem, probably you've heard of that before. My guess is that in Algebra 1 you dealt with it. Maybe if you've already had Algebra 2, you've seen it again. Probably in pre-algebra and even in 6th and 7th grade math, you dealt with Pythagorean Theorem. It's one of the more famous theorems in math, and it's something that many different textbooks and many different levels of math deal with. So let's go ahead and jump into it. Look down at your book on 211 and look down here at the screen. Pythagorean's theorem states, this is theorem 62, that the square of the hypotenuse of a right triangle is equal to the sum of the squares of its legs. Now, I think you probably have seen it written a squared plus b squared equals c squared. Okay. Now in geometry, we're going to write it just a little bit different than that, although you can use that in geometry. Typically, in geometry, you're going to see it written as this. Something like AC, that's a leg, squared, so AC squared, plus CB or BC squared is going to equal this sum down here. This is the hypotenuse squared. So it's going to look more like this. It's going to look like AC squared plus BC squared equals AB squared. Now, that's the same thing as if we used our letters. So across from this is going to be small letter A. Across from this is going to be small letter B. And then across from this is going to be small letter C. So that's what we normally use are the small letters instead of the actual lines. But in geometry, you're going to see it written like this a whole bunch. So you could write it like this. And this one would be B squared plus A squared equals C squared. And that's fine. This is Pythagorean's theorem. This is also Pythagorean's theorem. So it doesn't matter which way that you write it. Both of those ways are going to work. All right. So theorem 62.1 states that the difference of the squares of the hypotenuse and the square of the one leg equals the square of the other leg. What does that mean? You can also write Pythagorean's theorem by writing it something like this. A squared equals C squared minus B squared. Where does that come from? Well, that just comes from actually taking this right here and just like subtracting a squared from both sides, right? So you get b squared equals, So it's just basic, simple algebra. So you could also have b squared equals c squared minus a squared. That would be fine too. All of these, basically everything that I have written right here, are all different kind of versions or ways to write Pythagorean's theorem. All right, so the key is that you remember a squared plus b squared equals c squared. Okay, and if you can remember that, you will be able to solve out the Pythagorean theorem. A couple more things in this lesson, and then maybe we'll do one of these. The Pythagorean triplets. You may or may not have heard of that before, but Pythagorean triplets are a group of three positive non-zero integers that satisfy the Pythagorean theorem. What does that mean? Well, here is a set right here of Pythagorean triplets, and here's another set of Pythagorean triplets. In other words, if we plug those into Pythagorean's theorem, it actually comes out to be no decimals, no irrational numbers, no fractions, nothing like that. It's all positive integers. So we could say that 3 is a squared, and 4 is our b squared, and 5 is our c squared. So we'll say 3 squared plus 4 squared plus equals 5 squared. And let's try it. So 3 squared is 9 plus 4 squared is 16 equals 5 squared is 25. Is that true? 9 plus 16 is 25 equals 25. And yes, that is correct. So yeah, that's one of the Pythagorean triplets. You could also go ahead and in this space, you could try some other things and just see, okay, what is that, does that work for everything? So I don't know, let's try 6, 7, and 8. Let's see if that will work. Since 3, 4, and 5 worked, maybe 6, 7, and 8 will work. So let's try it and see if those actually come out. So 36 plus 49 equals 64. Well, 36 plus 49 equals 585. 85 equals 64? No, it does not. So in other words, that doesn't check out. Those are not Pythagorean triplets. So 6, 7, and 8, that doesn't work. There's a few that do. You could also do 6, 8, and 10. Check this one out. 6, 8, and 10 also work. So if I have 6 squared, I have 36. 8 squared is 64. And 10 squared is 100. 36 plus 64 is 100 equals 100. So these would be Pythagorean triplets. So we could add that to the list. 6, 8, and 10. Also Pythagorean triplets. And you could keep going with that and come up with more Pythagorean triplets. All that means is you don't get any decimals, you don't get any fractions, you don't get any square roots, anything like that when you're done. They all are positive integers. One more interesting thing that this lesson gives you right down at the bottom, and I'm not exactly sure why they give it to you here, but I guess it's as good a here as anywhere. So bottom of page 211, it says, a constant is a value which remains the same throughout a given process. Remember, there's really two things. You should know this from algebra class, right? There's a variable. The variable is always changing. And then there's a constant. The constant stays the same throughout the process. All right, let's do one of these problems. I kind of picked one of the harder problems on page 212. Let's do number 4. And I've kind of got it written out here just a little bit. So we have our triangle. This is kind of a little bit of the last lesson and then this lesson. So that's why I kind of wanted to do this problem with you. So we have BC. So this BC right here is 24 inches. We have BD, this little section right here, is 14.4 inches. And it wants us to find AB. So that's this guy right here, this big one right here. So that's a question mark. That's what we need to find. And then it also wants us to find AC. So this one right here is a question mark. And then it wants us to find DC, so this altitude right here. So there you go. So where are we going to start? Well, I might as well start with this little triangle right here. Let's find DC first. That one kind of makes sense to me. So this is going to be a squared plus b squared equals c squared on this little triangle. Plug in our numbers. So 24 inches is our hypotenuse. So that's going to be equals 24 squared. And you got to put the parenthesis around it because it's not just the 4 that's getting squared. It's the whole 24. So I'd want to put that in parentheses. And then this is going to be, we'll call this the A. It doesn't matter if you call it the A or B. We'll call this the A is 14.4 squared. And then that would be plus B squared. So a little bit of geometry would tell us that we need to subtract the 14.4 squared from both sides. So this is going to end up looking like B squared equals 24 squared minus 14.4 quantity squared. Let's save just a little bit of time and effort here. Let's get out the calculator and let's go ahead and solve this using our calculator. So 24 squared is going to be, you could do 24 times 24, or you can just do that little x squared button or whatever. However you work your calculator, it's fine. Everybody's calculators are different. So we have 576. So b squared equals 576. And then we're going to go ahead and clear that out, and we'll do the 14.4, and then we'll just square that. And that equals 207.36. 207.36. All right, so go back to the calculator here, and we're just going to do that. So I'm going to actually do answer. And then I'm going to cheat just a little bit. So I'll do 576 and then minus the answer. So just kind of work that around there, and we end up with 368.64. 368.64, and that's still b squared, right? So we have to square root both sides here to get b. So b equals the square root of 368.64. We would then say that b is approximately equal to, and we use that little bacon right there to say that it's approximate. It's not equal to it. So when we go to the calculator to do the square root of that, it's not going to give us an exact answer. It's going to give us a rounded off answer. So we'll do the square root of 368.64. And that's going to tell us that the answer is 9.2. Okay? So 9.2 would be our rounded off answer. Okay, so 9.2, we would go ahead and say that this is 9.2. What you would do from there is you would continue to go around the triangle to figure these things out. Now, here's the problem. We already kind of come up with a little bit of a problem right here. And our problem is that we're missing too many sides of this big triangle, right? So if we want to do the big triangle, we want to find that we don't have this missing piece right here. So now what you need to do is you need to go, and I'm going to kind of leave you hanging here, right? I'm going to make you do the work right here. You need to go back to last lesson, and you need to kind of manipulate that triangle around, and you need to say, okay, so, all right, so I have this, but I'm missing too much there. So now I need to use a mean proportional. Remember, this is a mean proportional with a couple different things. We can find this mean proportional with, remember, it's a mean proportional of this right here. So in other words, I'm going to give you just a little bit, but you could do AD over our mean proportional, which is 9.2, equals 9.2 over the other piece of the hypotenuse there, which is 14.4. Now you can just use a proportion to figure that out. I would actually, instead of AD, I would use X there. So I would say 14.4X equals 9.2 squared. Okay? And then just work that, do that math, and then you will get the next piece. What's the next piece? The next piece is going to be this right here. Then in order to get the whole thing, you would add those two pieces together, right? And then that would give you AB. Once you get AB, then you could very easily find AC from that information. So lots of fun there. I know you're like, oh, I can't wait to do that, Mr. Steve. I love these problems. Yeah, I know you love these problems, right? So they are challenging. That's what geometry is all about. It's to challenge you and to make you think. So hopefully it's doing that for you. And, try to embrace it and try to, treat it like a puzzle and figure it out. It can be fun if you let it be fun. All right. That's all I've got for you. Hope you learned something there. If you missed anything, make sure to go ahead and slide it back. Watch it again. We'll see you later. Have a good one. Bye-bye.